Okay, so continuing with 6.4, number 2. Okay, so we have 2 sine squared of phi over 3 minus 3 sine of phi over 3 minus 5 is equal to 0. So let's rewrite this in green. So we have 2 sine squared of phi over 3 minus 3 sine of phi over 3 minus 5 is equal to 0. So I'm going to do a u substitution. I'm going to let u be equal to sine of phi over 3. So what I get then is 2u squared minus 3 times u minus 5 is equal to 0. So I'm looking for 2 integers that have a product of 2 times negative 5 is negative 10 and a sum of negative 3. So that's going to be, of course, negative 5. Or let me do it the opposite way just so it's easier. Let's do positive 2 and negative 5. Positive 2, negative 5. So I'm going to rewrite my linear factor. My linear factor. So 2u squared plus 2u minus 5u minus 5 is equal to 0. And then I can factor by grouping. Let's do this in yellow. So looking at the first 2 factors, it looks like there's a 2 and a u common. When I factor that out, it looks like I will have a u plus 1 remaining. Looking at the second 2 factors, it looks like I have a minus 5. And when I factor that out, I will have a positive u and a positive 1 remaining. So that is, I have a factor of u plus 1 common to both terms. But remember, u was a placeholder, and it was a placeholder for sine of phi over 3. So I can now rewrite this as sine of phi over 3 plus 1 times a quantity twice sine of phi over 3 minus 5 is equal to 0. So in the first case, we say, okay, so sine of phi over 3 plus 1 is equal to 0, which means that sine of phi over 3 is negative 1, which means, let me rewrite phi over 3 in purple. Okay, so at what angle is sine negative 1? And that's 3 pi over 2, down at 270, right? Which means that phi, when I solve for phi, multiply through by 3, will be 9 pi over 2. However, that is not between 0 and 2 pi, so we don't include it. It's not a solution in the given interval. We have to be between 0 and 2 pi. Well, let's try again. Let's go to the other factor. So 2 sine of phi over 3 minus 5 is equal to 0, which means that 2 sine of phi over 3 is equal to 5, which means that sine of phi over 3 is 5 halves. Well, that's not on my unit circle. But I know that phi over 3 will be inverse sine of 5 over 2. Okay. Is there another possible solution? Well, there should be one. Or Actually, let me color code it. It was yellow, remember? The two solutions. So pi minus inverse sine of 5 over 2. Okay, however, I want to solve for phi, not for phi over 3. So I'm going to multiply this whole thing through by 3. And I get that phi will be equal to 3 times inverse sine of 5/2, or 3 pi minus 3 times inverse sine 5 over 2. And there we go.